Hey math kids, today we're going to talk about how placing numbers in different parts of a graph affect what it looks like, as well as odd and even functions. So these are generally called translations or stretches or whatever, just for modifying graphs. So the first thing I actually want to do, I want to go to Desmos. So desmos.com, and then go to the graphing calculator. And we're going to just look at basic parabola. So just x squared. And that's what it looks like. Now, if you add 3 to that, just see what it does. So it's at 0, and then it jumps up to 3. Okay, so you can make a conclusion about that whatever we add here changes the y-intercept, or it changes the vertex, actually more correctly, like that. Okay, so minusing 3, whoops. If we subtract 3, it did the same thing, but moved down 3. Okay. Now, if we do this, put 3 on the inside, it makes it skinnier. It's actually skinnier by a factor of 9 because the 3 is getting squared as well as the x. So it actually is the same thing, notice, as saying 9x squared without the parentheses. Okay. Now, what happens if we do x plus 3 inside? Well, this is actually counterintuitive for most students, but it moved to the left. So we actually moved to the left, or in the negative direction. So we put a plus sign here, we get a negative. So as you might have guessed, is if we put a negative, whoops, if you put a negative, you actually move to the right 3. Now, I encourage you to do this yourself on Desmos, because I think you can learn it a little bit better. Now let's look what a negative does. Negative just flips it upside down. So we have an upside down parabola. Okay. All right. Now, hopefully you developed some understanding of what was going on there. If not, go back through the examples and try to see how that 3, when we change it to positive, negative, put it in different spots, see how it affects the graph and try to get an understanding, because that's going to be true for all graphs. For example, if we start with absolute value of x, we get this V shape. And then if we add 3 to that, it just moves up 3, like the last one. So see how it moved from the 0 to the 3 right here. Okay, anyway, I'll leave the rest of that for you to play around with. And we'll get to doing some of these odd and even problems. So the definition of even, like an even function, is if we plug in negative x to a function, we'll get the original function back out of it. Definition of an odd function, if we plug in negative x, we get negative f of x. Okay. Now this might seem really confusing, but visually, so feel free to graph things if you ever are confused, but visually an even function is symmetric about the y-axis. So y-axis symmetry. So do you see, if I use the y-axis, I could fold across and it would line up perfectly with the other half. So I fold this way, and then I just get this piece. Okay, hopefully that makes sense. Now, odd functions are a little strange. So they would look like something like this. So I think of it as a double symmetry. It's called symmetric about the origin, but I think of it a little bit different than that. So I would first fold across the y-axis, and I'd get something that looks like that dotted line, and then I fold that across the x-axis. So if I can fold this piece to here, and then I fold it down to here, it would make the same piece of the graph. So once again, this was odd. This is a visual definition of odd, and this is a visual definition of even. Now, to be more exact, sometimes it's better to use an equation. And so if we just want to state whether something is odd or even, and we're given an equation, let's try one like this. So x cubed. So what we're going to do every time, we don't know if it's odd or even, we just plug in a negative x and then simplify. Well, if we had negative x times negative x times negative x, these two would combine to make x squared. And then if we do this, it would be negative x cubed. So we take this, we compare it to the original. In an odd function, everything will look the same except for all of the signs will change. So because this was positive, now it's negative, that's an odd function. Okay, let's try another one. Let's try x cubed plus 5. Now you might have a hypothesis on whether or not this is odd or even, but let's see what happens. So we plug in a negative x. We go through the process. Negative x cubed is just negative x cubed without the parentheses. We saw that on the previous one. Now we compare this to the original. When we do that, we see that this changed because up here it was positive, now it's negative, but this stayed the same. So for it to be odd, everything has to change. All the signs have to change. Okay, for even, all of them have to be the same. So since one changed, one did not, this is neither. It's neither odd nor even. Okay, k of x equals x to the 4th. So let's try that one. Put in a negative x. Negative x to the 4th would be negative x, negative x, negative x, negative x. So that's x squared times x squared, x to the 4th. Compare that to the original. And since the signs are the same, this is an even function. If you need additional help, please come to Math Lab. Until then, calculator.